Hi, welcome to Educators. This video we are going to cover matrices. Matrices are a foundational element of linear algebra. Matrices are used throughout the field of machine learning in the description of algorithms and processes, such as the input data variable when training an algorithm. The topics to be covered are: how can we define a matrix in Python, how to perform element-wise operations such as addition, subtraction, and product, and how to multiply the matrices together. For more mathematical approach, you can use the given link below, Dr. R.K. Education and Guidance. You can get more detailed mathematical approach for these concepts. In this video, we are going to cover these concepts using NumPy in Python. For that, we are taking a Jupyter notebook. First, we'll see how can we define a matrix in Python. What is a matrix? A matrix is a two-dimensional array of scalars with one or more columns and one or more rows. So, how to define it? For that, we need to import an array from NumPy. From NumPy, import array. A is equal to array of 1, 2, 3. I am going to take 2 rows and 3 columns. Now we can print this A with the help of print. Now if you run this, you can see an array or a matrix with the 2 rows and 3 columns. 2 matrices with the same dimension can be added together to create a third matrix. So for that, how to perform matrix addition? The same thing you can take. I am just copying the code given above. So this is my first matrix. Now I need to define a second matrix. B is equal to array of the same elements I am going to consider. Right. Print B. We want to add A and B matrices, and the resultant matrix is going to be our C. Print C. If you run this, you can see 1, 2, 3, 4, 5, 6 are the A matrix elements. This 1, 2, 3, 4, 5, 6 are the matrix B elements. After performing A plus B, we are getting a resultant matrix which we are storing it in C, and when we print this C matrix, we are going to get 2, 4, 6, 8, 10, 12. How it is going to perform this? If you look here, this is very much equal to C of 0, 0 is equal to A of 0, 0 plus B of 0, 0. Similarly, C of 1, 0 is equal to A of 1, 0 plus B of 1, 0. This is how element by element addition is performed if you are using A plus B here. So 1 plus 1 gives you 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 4, 8, so on. This is how matrix addition is performed. Now coming to matrix subtraction, you can see I'll copy the same code and just I am changing, instead of plus I am going to take minus. So one matrix can be subtracted from the other matrix with the same dimension. If you look here, both the matrices A and B are of same dimensions, 2, 3 and 2, 3. So if you run this, you can see 0, 0, 0, 0, 0, because we are subtracting matrix B from matrix A. As both the matrices are having same elements, the resultant matrix we are getting here is a set of zeros. This is how you can perform matrix subtraction. Coming to matrix multiplication, this matrix multiplication is an element by element multiplication. This is also called as Hadamard product. Two matrices with the same size can be multiplied together, and it is also often called as element-wise matrix multiplication or Hadamard product. This is not typically a matrix multiplication, so therefore we'll be using a different operator to represent mathematically. So we'll be using a circle. C is equal to A circle B. So you can see here, if you look, C is equal to A circle B. This is how generally we are going to represent this Hadamard product. Now coming to this, how can we perform this in Python? So again, I am copying the same array elements. Now instead of minus, here I am going to take star. And the star is an operator used to perform matrix multiplication, that is matrix element wise multiplication. Now if you run this, we can see 1 into 1, 1, 2 into 2, 4, 3 into 3, 9. So element by element multiplication is performed. So this we can call it as Hadamard product. This is mostly used in deep learning. Coming to matrix division. Now coming to matrix division, one matrix can be divided by another matrix with same dimensions. Example, C is equal to A by B. Now, how can we do this in Python? So, here instead of star, I am going to replace this with slash. Now, if you run this, you can see 1 divided by 1 or 1 slash 1 gives you 1, 2 slash 1, which is going to give you the quotient. So this mathematical representation, it is represented as C of 0, 0 is equal to A of 0, 0 slash B of 0, 0. Similarly, C of 1, 0 is equal to A of 1, 0 slash B of 1, 0, so on. Now we'll see matrix multiplication. It is also called as matrix dot product. It is represented as C is equal to A dot B. So coming to the rules here is, in this matrix multiplication, if you are going to consider two matrices A and B, A must have the same number of columns as B has rows. Example, if A is of shape M by N and B is of shape N by P, then C, that is the resultant matrix, is of shape M by P. Now coming to this, how can we do this? The same copied. Here I am going to change the array values. Okay, so here I will be taking 1, 2, right? comma 3, 4, 5, 6. And here I am going to take a B matrix of size, different size. 1, 2, I will take just 3, 4. Now I need to perform a dot operation. C dot is equal to A dot B. So here A dot operation, that is dot function, dot of B. So this is how you need to do matrix by matrix multiplication. C is equal to A dot of B. Now if you run this, you can see a matrix like 1, 2, 3, 4, 5, 6. A matrix. Coming to B matrix, the elements are 1, 2, 3, 4. And this is a matrix which is of size 3 by 2. And this is of size 2 by 2. So the results of this matrix we got as 3 by 2. So how it is done mathematically? Now if you take C of 0, 0, we will see how this 0th element, C of 0, 0, that is 7, has occurred. Now is equal to A of 0, 0 into B of 0, 0 plus A of 0, 1 into B of 1, 0. This is how this dot function has performed this multiplication. 0th element into B element plus 0, 1 element into 1, 0 element of B. This is how we get the resultant matrix after performing matrix multiplication. Now coming to matrix vector multiplication. A matrix and vector can be multiplied together as long as the rule of matrix multiplication is observed. Now, how to perform matrix vector multiplication? For that, you can take an array A, right? I am going to define a matrix B as B is equal to array of 0.5, 0.5. And if you are trying to print B, and next you need to perform matrix vector multiplication with the help of dot function, dot of B, and print C. Now if you run this, yes, here coming to this, I have taken this braces. Now if you run this, right, this is the matrix vector multiplication. This is your A matrix, this is your B matrix, it is your vector, and the resultant is 1.5, 3.5 and 5.5. How it is performed? The same way as we have seen in the previous example, C of 0 is equal to A of 0 comma 0 into B of 0, which is the 0th element in B, plus A of 0 comma 1 into B of 1. This is how it performed the operation. Next we'll see matrix scalar multiplication. Now coming to this matrix scalar multiplication, you can see a matrix A, I am reading, and coming to B, scalar, it's a single value. B is equal to some 0.5 and C is equal to A into B. Print C. If you run this is how you can get the output. This gives you matrix scalar multiplication. Right? Now, how it is done? C of 0 comma 0 is equal to A of 0 comma 0 into B. Again, C of 0 comma 1 or 1 comma 0 is equal to A of 1 comma 0 into B. This is how this matrix scalar multiplication is performed. And coming to this matrix multiplication, we have seen that matrix multiplication by using a dot function, right? You can also make use of one more operator to perform. Here you can take one more variable D is equal to A. You can use @ symbol, @ and B. Now we are going to print D. Now if you run this, if you look into this, if you are using A dot function of B, you are getting the resultant matrix as 7, 10, 15, 22, so on. If I am using A @ B, the same result I am getting. So you can make use of either the dot function or @ operator to perform matrix multiplication. I hope it is clear. Thank you for watching.